All right, so there's lots of different types of graphs that are used in statistics. We have a bar graph. We have a line graph. We have a bar graph, but it goes in the horizontal position. You can have a pie graph. This is a picture graph where each one of these little symbols represents $10. So, for instance, on Thursday, you spent $10, $25. This is a histogram, a frequency, another histogram table, histogram of call waiting times, of Old Faithful eruptions. And some of this data follows what we'll call a normal distribution. So anytime you have data that kind of follows this trend where it kind of slowly goes up on one side to a peak and then down the other side, uh, we'll say that it has a normal distribution. So anything that has this normal bell curve is a normal distribution. And there's lots and lots of things in real life that follow this kind of a curve. Your normal bell curves can have various shapes, but they all will be symmetrical and they will all have a high point at the middle or the average data. So birth weight would follow this standard bell curve, patient weight, hundreds of pounds of waste. And you see on this one, they've kind of broken it down into pieces, and we'll talk about what those pieces mean in a little bit. Sediment, whoops. Hold everything. Technical difficulties. Men's height, average women's height. Here is men and women on one chart. So the frequency of women is more. They just interviewed more people. Their average height is 65 inches. A man's average height would be 70 inches. Right, and there's lots and lots of data that you can see would follow this pattern. Right, even the guesses that people guessed how much cash Brad Pitt had in his wallet follows a normal distribution. SAT scores, and so on. Age that people get married. All right, so when you have this normal distribution, this middle line here is always going to be your mean or your average. Each one of these bars is one standard deviation. So this is one standard deviation away from the mean in the positive direction. This is one standard deviation of away from the mean in the negative direction. This red zone would show you 2 standard deviations away, and this yellowish zone will show you 3 standard deviations away. So this will tell you 68.2% of your data falls within this blue range. 95.4% would be within 2 standard deviations or plus or minus 2 standard deviations. And 99.7% of your data would fall in between plus or minus 3 standard deviations. All right, and so please note that again, everything is going to be symmetric around the middle, which is your mean. And it's going to, each one of these bars is going to be a standard deviation. So if you Google this chart, standard distribution, you might get slightly different percentages. So just use whatever percentage I give you either on the homework or on the test. And let's see how this works. I'm going to switch over to another screen, so bear with me for one moment. All right, so let's take a look at an example here. At a local high school, class begins at 7:30. The average arrival time is 7:25 with a standard deviation of 5 minutes. On an ordinary day, what percent of the students are late? So this 7:25 that they mention here is going to be your mean. So let's write that right in our chart. So this here would correspond to 7:25. Well, each standard deviation is 5 minutes. So this here would be at 7:30. This here would be at 7:35. This here would be at 7:40. In the opposite direction, this here would be at 7:20, 7:15, and 7:10. Now that we've written our data in on our chart, let's go ahead and answer the question. On an ordinary day, what percent of the students are late? Well, school begins here at 7:30. So anyone that arrives after 7:30 would be considered late. So all we have to do is add these three percentages up, and you would find out that it would be 15.8%. 15.8% of the students would be late on any given day. Let's take a look at another example. Same data at a local high school. Class begins at 7:30. The arrival time is at 7:25 with a standard deviation of 5 minutes. On an ordinary day, what percent of the students arrive before 7:20? Well, if you remember here, our mean is 7:25. Each standard deviation is 5 minutes. So this here would be 7:20. If we want to know how many students arrive before 7:20, we're looking at this part of the chart. And once again, we just have to add up these three pieces of data, and we'll know what that answer is. Well, on the previous one, we added up this data, and we know our chart is symmetrical, so this data would be the same thing. So we know the answer to the question would be 15.8%. Another example is, again, the same data, but now they want to know on an ordinary day, what percent of the students arrive between 7:25 and 7:30? Well, this here is going to be your 7:25. That is our mean. One standard deviation away here would be 7:30. So they're asking about this part of the chart, and you just have to read it, and it would be 34.1%. And if we ask another question, all right, on an ordinary day, what percent of the students are not late for school? Well, school starts here at 7:30. So all of these students here would be considered not late. So you could just add up all of this data and you'll find out that the answer would be 84%. So 84% of the students are not late for school. And the last way that we could ask a question would be to give you a little bit more information and tell you that there are 200 students. How many of them are late for school? Well, again, this here is 7:30. This is when school begins. Any student arriving over here would be late for school. So we know that this is 15.8%. Let's change that to a decimal and then multiply it by 200. And you would get 31.6 or 32 students would be late for school on any given day. And when we're talking about people, we're still going to use just normal rounding rules. So we will round up to 32. If you have any questions, let me know.